So our circuit boards have arrived for the Raspberry Pi trivia game. We ordered 5 of these boards from a PCB manufacturer in China, actually. They're quite good quality, very economical. These are designed to socket directly up to the GPIO socket of the Raspberry Pi. We built 5 boards. We started adding components to this board. We've added the resistors, transistors, and we're going to continue to build this board out and test it. The way this board works is it connects up to the GPIO, and the GPIO controls the lights, the LED lights, to the various buttons. It also receives signals from the buttons so that when the player presses the button, it can be sensed. It has an extension terminal block so that we can hook up an external siren or light just for special effects. And that's where the relay will be used so that we can provide additional current for that particular device. So this is the RJ10 or RJ9 connector. We decided that it's very economical to use these. The cables are very cheap to connect to the buttons. This is the relay for the external alarm device or lights. And we're going to start building these circuits and test them out. This is the Raspberry Pi 3 B+, and you'll see that the circuit board is designed to socket directly up to it, sit right on top of it like a daughter board. So there will be a connector that we'll attach here, this connector. This will allow us to plug it directly in to the Raspberry Pi circuit and connect up to the GPIO. That'll make a very compact unit for this trivia game circuit. That way we can mount it in a very small space. Okay, so let's start assembling the rest of these components. We've already installed some resistors and transistors. We will put these connectors on. The connectors are for connecting to the button assemblies. So we'll get a couple of those snapped on. It's perfect fits. This particular component, when we designed the circuit, didn't have any what we call part footprint models. So we had to create our own footprint, and we use Eagle design software for our board design and layouts. So I'm really impressed that that's such a nice tight fit. So we will snap these on and see if we can get some assembly going. All right, we should have 5 of these. These are making nice, going on fairly well. So we have our solder iron ready to go. We'll get these tacked in really quickly. 2 more to go. There. So we'll check those connections, make sure we don't have any cold joints. They look fairly good. So the button controls will plug into that. Here's a button assembly. It's basically a box we built. We'll include that in the design and the kits. So here's a button control. And there are 4 leads, one for the LED and one for the switch. 2 for the switch and 2 for the LED. It uses a, here we have an RJ11, it's a little bit large. We'll shave it down, or we'll put an RJ10 or RJ9 connector on. And the reason is we needed to save the real estate space so that we could fit all of these connectors on this surface. As we had mentioned earlier, the whole idea is that this will just socket right up on top of the Raspberry Pi 3B Plus, so that it's a very compact assembly. So this connector is going to mount on the bottom of the board and is going to mate up to the Raspberry Pi connector, as you see here. So we're going to mate that up. We're going to tack that in really quickly. Just a couple of solder joints. It'll take a few minutes to get that. We need to make sure it's nice and flat against the board, and then tack 2 alternating pins really quickly. That's pretty straight, pretty flush. You want to make sure it's nice and uniform and flush. Now once we continue to solder all the pins, it'll be nice and sturdy. Each of these boards has a relay, so we can drop this relay on quickly. Now I have a handy gadget here to help hold these boards and hold things in place, but for filming this it's a little difficult to show it. So sometimes we'll use a trick, like we'll use a spacer to kind of hold the component in place and nice and flush against the board while we tack a couple of leads, and then we don't have to worry about it. It looks like my solder iron needs to be reset. This is on a 2-minute timer. It's a Weller. It tries to preserve the tip integrity by timing out it periodically, and I have it set on 2 minutes. So if I'm not soldering within 2 minutes, it'll start to lower the temperature. So let's give it a moment to catch up. Now we're soldering this type of circuit and these components. You want to solder at about 750 degrees. You don't want it too hot, otherwise you will damage the components. We'll drop that in. Now it should be affixed so we can finish the soldering. Now there are a few caps on this circuit that we will apply. And to get those caps in place, I have a cap kit here. Just give me a minute. I'm going to try to find that that cat kit. Now what we spec'd was 220 microfarad, and these are in order to filter the line voltage, the power supply, to make sure we don't introduce ripple, because we're adding additional loading supplied from the Raspberry Pi. In our next session, we're going to actually go back and look at the design of the circuit. And we're going to look at how we designed it in Eagle and go through a few steps on how to use Eagle to design this circuit and do board layout. So for a 220 microfarad would be about this size here. Here's a 220. We'll talk about why we chose 220 in our next episode. But we want to make sure we get the polarity right. You'll see here these are marked positive and negative. So we want to make sure we definitely get the polarity right. These capacitors will pop if you get the polarity incorrect. And one more. Another 220. All right, let's double check. Positive, positive, and positive. I want to make sure that's correct. So we got negative, 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 oriented to negative. Now, a similar type of situation, we want to make sure the components lie nice and flat when we solder them. So we'll kind of just use that spacer, that little bit of static foam to hold it in place while we tack a couple of these leads. So this pretty much covers all the components on this circuit board, except for a little jumper, a 3-pin jumper. That's so that we can select whether we want 5 volts or the 12 volts that we could supply, or whatever other voltage through here for our common into our button indicators. Our button indicators, this particular button indicator was the most economical I could find, and has an LED lamp, but it's a 12 volt lamp. So built into the lamp assembly, it has a resistor to drop the voltage. But oftentimes you can find buttons with different types of configurations. There'd be 5 volts, 12 volts. So we designed this so that you can supply your own voltage through this terminal strip and select which voltage you want to feed the lamps for the button assembly. So it gives you flexibility. So there we are, it's coming together. I'm going to finish building this circuit out, and then we're going to come back in the next episode and we're going to talk about the design with Eagle and understand how we designed this circuit, how we did the board layout, and all the details associated with that. And then we're going to follow up with the live hookup to the Raspberry Pi, and we're going to test it out for the first time.